I'm Susan Johnson. I worked at NASA Glenn, which is in Cleveland, Ohio, for about 46 and a half years. And I've been in the aeronautics side of NASA my entire career. I'll even say as a side note, I've actually been down to Muncie, Indiana quite a bit because, Muncie has the National Model Airplane field down there. So our Model Airplane Club always sponsors a couple contests each year. So we're always heading down there to visit Muncie. So occasionally we drive by Fort Wayne. So anyhow, I was just a little side note, but yeah, the NASA Ingenuity helicopter is a very interesting little vehicle, and it all came about even back in the 1990s. The aeronautics folks in NASA were thinking, well, we hear about all this space exploration, but would it even be possible for helicopters to fly on another planet? And so even back in the 90s, our team was kind of looking at that to see if that was even doable. And again, materials and structures and everything else mature over time. And so we started running the numbers again back in the about 2012, 2013, and looked like it was pretty viable. So when the space side of our agency approached us saying, could we possibly prove that a helicopter can fly on Mars, we had run the numbers and said, yes, but you've definitely got to build it a certain way. So this is the story of the Ingenuity helicopter in a nutshell. Hopefully I got about an hour here to do this, so I can kind of go through this. I was in the project of the Revolutionary Vertical Lift Technologies Project, which is the aeronautics helicopter program. And we did a lot of terrestrial helicopters work, but we did have a number of people dedicated to running these numbers for the space science side of the house. And it was quite a feat when it was all said and done. So let's see here if I can change my slide. Let me see here. First of all, let me get into, all right. Can I do my next slide here? Okay. You see the slide change there?
Yes.
Okay, great. All right, thank you. All right. So the helicopter obviously didn't go on its own. It had to ride on the Perseverance rover. And the Perseverance rover is the largest, most sophisticated rover that we've ever sent to Mars. It had a lot of cutting edge technology. We put a lot of instrumentation on this one, more than any of the other rovers we had put on it up to this point. And this one was really going to start looking at how we could really get a human on Mars. So as I use the word hitchhiking on the rover is the helicopter Ingenuity. It became the first aeronautics vehicle. It only weighs about 4 pounds to fly on another planet. So that's a first for aeronautics. And it was stored underneath the Perseverance during its ride to Mars. So kind of a quick look at the helicopter itself. It needed to have the ability to fly in about 1% of the atmospheric density of what Earth is. we had, let's see, do I have I don't know if I can, where's a little pointer here? Let me see if I can find it. Oh.
Your mouse is visible on the screen.
Can you see it?
Oh,
okay,
yeah.
Great.
Absolutely. Yeah, if you want
Okay.
a slideshow, we could be full screen, but it's up to you. You know, we see the side panel, obviously now.
Yeah, okay, all right. That's fine. I was just trying to figure out how to move my slides, but apparently I have to. I can't use my up and down arrows for some reason, so I'll just kind of use the ones off to the side. So you'll see what's coming up too. Okay. So the Ingenuity helicopter actually has, it's a coaxial helicopter, meaning there's two blades on it. They're counter rotating to each other, so that kind of keeps it nicely balanced when it's in flight. It only weighs about 4 pounds. It's solar powered. It's this, well, it ultimately was designed to be square, but this is where the location of the solar panels are. It only has enough charge for 90 seconds of flight. Again, these are the design numbers. It takes about 1 to 2 days to recharge. We said it could go up to about 984 feet. Or has a range of 984 feet. The height is about 15 feet. It's a totally an autonomous flying vehicle, which means we do not have someone controlling it while it is flying. It has the program, it's programmed to fly its flight, and then we'll find out if it actually worked afterwards. It needs to be able to survive the cold Martian nights, and it communicates via the rover. So it cannot communicate directly to us from Earth. It needs to send its signals to the rover, and then the rover sends any of the communication back. I won't get into this too much, but you know, here's the 4-foot blades. These are carbon fiber blades. They have a foam core in the middle of them. It's a very simple landing structure, nothing complicated. It's just kind of a little spring-loaded legs there. The box that all the sensors and the cameras are in is about the size of, I would call it a boutique Kleenex box. A lot of it was using a lot of the electronics and components are from the cell phone technology. It has it's a cube within a cube because we have a CO2 gas cap to gap to insulate it. And as I mentioned before, the solar panels and the communication. And so it has lithium ion batteries. And again, it goes for about a 90-second flight. So just backing up a little bit, we've actually had a lot of exploratory bodies that have been sent to Mars, and it's been the most explored body in our solar system. We started actually looking at Mars during some flybys. So we had the Mariner series, so they fly by Mars first, and then we got a little more sophisticated to do orbiting around Mars. Then there's the orbiters and the landers, so that actually now penetrates into the Mars atmosphere and lands. And I do remember that particular landing and the photos coming back from Mars at that time. Then we have the landers and the rovers. So now we're getting a little more transit around the surface. And then we have the rotorcraft called Ingenuity that is making flights over the Martian geography. And so, like a lot of things, you crawl, walk, and then run. Okay, so on to Perseverance itself. I'm going to just spend a little time on Perseverance because it was an important vehicle for us. So the helicopter was installed on the rover. This is the rover as they were packing it all up. And if you can see where the helicopter is, it's located right there. So it's folded up pretty tight underneath Perseverance. And then there was this kind of like a bedpan that went underneath this whole system here. So we launched on July 30th of 2020, and we've got the rovers safely tucked away in the rocket there. And I put this table up just to show there's some similarities and some differences. Well, Earth and Mars, there's a difference, totally a difference in size and a distance from the sun. But, you know, there's kind of some interesting similarities between the two planets. You know, their orbiting speed, the tilts of the planets. You know, length of days really aren't that far apart. But obviously the more tougher engineering feats here was, you know, dealing with the gravity and the temperature and the atmosphere. So why we send these probes to Mars is that we really want to understand life on Mars, and we want to understand the geology of Mars. You know, we're going to be roving around quite a bit. We plan on having a lot more sensors that are really going to be picking up the sciences and the geology. We're going to be putting this rover in a dry bed delta, which looks like it had some water in the past. So we want to look at the geology. We want to look at the astrobiology. And then this is important because we're going to be doing sample caching. So we're taking 30 core samples, and we're going to have Perseverance drive along. If there's a place that looks pretty interesting to take a core sample, we'll have Perseverance do that, and then it'll store that core sample, and then it'll drop it on the planet for future retrieval back to Earth. And then what we need to do to prepare humans on Mars. So Perseverance has a lot of scientific tools on it. I tried to color code some of these sensors because there were just so many that were on it. So it's a good listener. We have in blue a couple of microphones on the rover, so we are actually hearing what it sounds like. And you can go on the NASA website and hear some of the Martian winds, or the winds, if you want to call them that, going by the rover itself. It has a 23 cameras, so there's just cameras everywhere on this rover, just looking at all sorts of different aspects and filters of the scene on Mars. We have a laser on it as well, and I've got to admit, I know it's on there. I'm not sure they've used it yet, but I think if they need to really break some rocks up, that they may need that, or if it needs to clear some sort of path, maybe, I don't know. Then it also has its own weather station. So we're now, again, it's the most sophisticated rover. We are now really getting a lot of the weather on Mars now, you know, in terms of the wind and the temperature and even the dust that we're so critical of watching. It is doing the sampling and the caching. And then I had a good friend who was actually involved in this MOXIE. This MOXIE was a little experiment that has already happened. It was to see if it could gather enough oxygen in the atmosphere to possibly have astronauts use it. And could they actually pull enough oxygen from the atmosphere? And then the test went fine. So I think future plans would be that they would just have to build a larger system to create more oxygen for future human use. Okay, so on to the Mars helicopter itself. This is the jet propulsion team. A lot of NASA folks were involved in this. Our science mission directorate was the group that funded the rover and the Mars helicopter. The NASA Aeronautics Mission Directorate actually ran the numbers for the helicopter. And the science technology, it has all the experiments and sensors and what they're really trying to gather with the rover as well as the helicopter. So again, a small team was started in 2014. We were running numbers earlier, obviously, but the helicopter wasn't officially initiated until 2014. And then we have all the other organizations, our contractors, AeroVironment, Qualcomm, and all the others listed there that were involved in that helicopter. And I'm sure you folks have kind of heard those 10 minutes of terror, how the system re-enters the Martian atmosphere. It's coming in hypersonically, obviously, and as it's entering the system, we've got the shielding, the maneuvering, parachutes. We had to test the parachutes to make sure they wouldn't strip away at that high speed. There's a heat shield separation. Again, everything's going to come apart slowly, if you want to call it that, and in pieces here. Everything to do to try to slow this rover down so it gently lands on Mars. So the shield drops away. We start getting a lander system here. The back shell separates with the rover separation, and then we have this descent crane here, the sky crane as we call it. That one's using rockets. It's still using rockets, and then it cables down, if you want to call it that. It just drops slowly the actual rover itself, trying to get things slowed away as fast as possible. And then once this sky crane knows it has contact, that the rover has made contact with the ground, it just flies away and just crashes somewhere else. So this was a very new science for us too, having these landing smarts on this particular rover. We knew it was going to go into a delta area, so there were going to be rocky areas and mountains and what have you. And so we needed a sensor system that was going to be able to, in real time on its own, figure out what it's got below itself, and then try to adjust a little bit to find and land into the Jezero crater. So it did do that on its own. And so I like this picture because this is a picture from one of the orbiters where it actually shows all the final landing spots of everything that took that to make that descent of the rover occur. Here's the parachute and the back shell over here. Here's the descent stage over here. Here's the heat shield over here. And then here's Perseverance right here. And so this is the crater that we wanted the rover to land in, because this one, after a lot of previous orbiting vehicles, this looked like a very good landing spot for us. So, okay, here we are back again with the helicopter underneath the rover. And so this is now a picture of Perseverance taking a picture of the helicopter after it's pretty much unfolded itself. It had a lot of unfolding to do, like an origami type of arrangement. And in this position, it's about 4 inches off the ground right now. And it's just being suspended by one more explosive bolt, and then it'll be dropped to the ground. So Perseverance landed on Mars February 18th of 2021. So we just passed its 2-year mark. This is Ingenuity showing it's just kind of hanging there by that bolt. And this is as of March 30th. And then Ingenuity is going to be deployed from Perseverance on April 3rd. Now, the thing with Ingenuity was that the space folks kind of thought the helicopter was a pretty risky idea to begin with, but you know, we were all willing to take that risk. And we knew it could be a really good scout. Because Perseverance can only go over so much terrain and types of terrain, whereas the helicopter could kind of fly over some of that rugged terrain. But we didn't know what was going to happen. And so we had an agreement that there would be a 30-day clock on this helicopter, and we were given 5 flight chances to make this helicopter work on Mars. And so once we deployed this helicopter, the rover was going to drive away and stand back because they didn't want Perseverance anywhere near the helicopter when it started its flight, and watch and see what happens. So our 30-day clock started on April 3rd. So this is a picture of Perseverance where it's dropped the helicopter. It actually, this is kind of a selfie of Perseverance and the helicopter way back here. So at this point, it's about 13 feet away. So it's just still rolling away from the helicopter. And then once it gets about 200 feet away, we do a couple of simple checks on the helicopter. We actually make the first flight on April 19th. And so here it is. It's down here at the bottom. And all we're going to do is do a very simple vertical flight up, just so many feet up, spin it up, see if it lifts off. If it does lift up, we're going to have it hover. We're going to rotate it 90 degrees, see if we can maneuver at 90 degrees. Going to hover it, make sure it still is stable. It can stay in one spot. And then we allow it to land. So that was the first flight of another air vehicle on Mars. But we didn't know that right away. Depending on where the orbit of Mars and the orbit of Earth are at any given time, we have anywhere from between 5 and 20 minutes to know what is going on Mars. And it took about 20 minutes for us to find out if the flight was successful. And it was. So that was good, very good. So as any good pilot does, they keep a flight log of all their flights of their vehicles. And so April 19th was our first flight, and we made our first 5 flights up to May 7th. So these are what we call technology demonstration flights, which meant, you know, is this concept going to even work? We proved it could work. Here was a stationary hover. Didn't go anywhere except straight up. It flew for about 39 seconds, you know, ground speed. And where we had dropped that helicopter was called the Wright Brothers Field. And then the second flight, we get it in a couple days later. We're doing a little more. We're trying to open up that flight envelope a little bit. And we do the 3rd, the 4th, and the 5th flights, and keep increasing that envelope. The flight time, we actually got it past its flight time because it looked like actually we had more charge than we needed. So we pushed the envelope there a little more on the flight time, and just kept pushing that envelope out. So then once we got the 5 flights accomplished, and it looked pretty stable, everything looked good. Everybody had discussions, and they said, you know, with the capability of what this helicopter looks like what it can do, let's see if it can then move into what we call a operational demonstration. So can we really press it into service for really helping the rover chart its path? Because, you know, the rover's cameras are only so high off the ground. And, you know, as we've kind of found on other rovers, it sometimes can miscalculate the type of soil it's going into or how rocky things are over a ridge or horizon there. So we're actually using the Mars helicopter to plot out the course for Perseverance. So we have now moved into what we call a operational demonstration. So I think we were all going to be happy if we could get another 5 more flights out of it to see how it would operate. But you know, we kind of kept going. You know, here's 14, and we were up to about 14. We found there was some servo issues. We had to fix that. We also were moving into winter, and everything stood down. We do not fly the helicopter during the Mars winter. And so here we are, Flight 43. Flight 43 was just made last week. I know when I spoke to Mike, and I thought, well, I knew we were up to about 42, but I had a suspicion there could be another flight before I made this presentation today. And so, yep, they did. They made Flight 43. And they have moved on from the alphabet to now they're starting the different places the helicopter lands. They've now started the Greek alphabet, you know, just from next point to next point to next point. So in total, the log is saying that as of February 16th, we've got 43 flights under our belt. If you count up the total distance, you know, I guess they said we've accumulated, you know, quite a bit of numbers here for a helicopter that we honestly did not know how well it was going to do. So the helicopter, again, it was a technology demonstrator, and that's first and foremost that we want to remember. You know, again, it's a baby step. We wanted to make sure the technology really could be proven first before we took it any further. So again, the first flight test of a powered flight on another planet, we had to build it light and strong. It had to fold up. It had to go through all of the testing like everything else, like the rover did. It had to go through the thermal and the vibration testing and everything that they do with all the other hardware that goes on a rocket because of the launches and the deceleration of those vehicles. So the helicopter had to go through that as well as everything else. It was powerful enough to lift off in the Mars atmosphere. It was designed to go for up to 90 seconds. And, you know, we know it's gone more than that now. And it's flying on its own. So we still have a crew that are dedicated to continuing to fly the helicopter. We've had change of some personnel, but most of them are still with the project. And like anything else, we try to test as much as we can on Earth here. And so this was one of the tethered tests we did in a vacuum chamber. We did this at JPL, so it was in a chamber, and it was showing stability with the criteria of what they were doing with, they were either testing the blades or the control system at that time. They did a number of tests depending on what the test required. This is kind of a fun picture. This is Ingenuity actually looking down onto itself, and this is the shadow of it on the Mars surface there. And then these are a couple of the pictures of the helicopter taken by Perseverance. One thing I like to do, you know, I started doing this when it was easy to do. It's getting a little more complicated now. I originally kind of had this top picture on flight 29. I had it on flight 5, then I would update it to flight. Here we are up to flight 29 in this top picture here. And this was, this white line is where Perseverance is going. That's their track. And then the helicopter is this yellow line. So you can kind of see they were pretty close to begin with. And then the helicopter kind of took a shortcut across these dunes here. And while Perseverance had to kind of go this way, and then the helicopter took another light shortcut over this direction here. So we can kind of see that Perseverance is limited by some of the geography in the area, and the helicopter is able to kind of scout ahead or look for some cool places for it to look at next. And then this picture down here, now I couldn't get an overlay of the helicopter on this lower right picture, but this one's kind of interesting in that we can kind of see it's going to start moving into this valley here is what I'm reading on the direction Perseverance and the helicopter are going to go. They think there may be even more indications of water, ancient water up that direction. But this also shows, this map also kind of shows where it's taking the core samples. And these core samples are going to be dropped here. They're dropped there. And then, like I mentioned before, they're going to be collected at a later date. But before I get to that, I sometimes get a question about Perseverance. The batteries are charged by a generator using the plutonium. So this is kind of how it's going to keep itself. powered up for the entire time that it's going to be on Mars. And so as long as our communications between helicopter and Perseverance all go, we should have some good communications and a long life for Perseverance, though I'm not quite sure how long this one's going to last. Some of the others have finally, earlier rovers have kind of conked out to their batteries, but I think this one's going to last longer. I don't know what the life is on this rover. But this is what's kind of what's next in the planning for Mars, is that we're going to try to retrieve these samples, but we're not going to put any humans on the planet to do that. It's all going to be by a series of rockets and a couple of vehicles that are going to be landing on Mars to collect it. So we've got this first one here. This is the rover, and then it's collecting its samples, and then it's going to be dropping the samples, which we already see has happened. And then there's going to be another vehicle here that is going to land, and that's going to be the vehicle that's going to wind up getting the core samples and flying them, or shooting them, maybe is a better way, is it rocketing them back to Earth. But it's this little retriever, they're calling it a rover or a fetcher. And this is what the original design of the fetcher was going to look like. But interestingly now, they've decided to scratch this fetcher and go with the helicopters. So, well, I kind of skipped through this chart a little bit here. I come down to this picture down here. It's going to be this little fetcher here, and it's going to have wheels on it instead, and a little grabber on it. And these are going to be motorized wheels. So the helicopter is going to fly close to the core sample, and then just kind of wheel up to the core, and then pick it up, and then it's going to put it back into that other retrieving system that's going to launch it back to Earth. So that was kind of a new change to the helicopter series for Mars. But what's kind of cool is that more than one type of helicopter is going to be put into space now as well. And so we have the Dragonfly that is going to journey to Saturn's moon Titan. And so this is a 8-bladed, again, it's 4, there's 1, 2, 3, and 4, and there's they're counter-rotating blades. And this one is going to fly on Titan. And this one is kind of far off there. It's supposed to be slated for launch in 2026, but this one's going to have a little better luck with the atmosphere. So it's 4 times denser than Earth. So they say this should be easily flyable on Titan. And then, like I mentioned, here's the little helicopter. They're going to build 2 of these and have them pick up the sample tubes, bring them back to Earth. So you can see the movie, and you can see a lot of information on a lot of links here on the NASA website. And like I said, it's a very innovative vehicle. You know, it was always one of those questions, did we think it really could fly? What's interesting is I just read that the those next series of 2 helicopters, they're saying that these blades have worked so well on this Ingenuity that they really can't improve on them for the next, those next two helicopter prop rotors. They've made them just efficient enough. They're doing everything they were expected to do. So they can't even improve on those. So they're going to keep the same blades. So this is actually a picture of the logbook. So what I listed there on the logbook on that other Excel spreadsheet is pretty much what they're copying down here. And I'd like to acknowledge the JPL engineers I talked to, and Todd and Bob and Susan Gordon, was my project manager as well. So we were all thrilled with the helicopter flying on Mars. And then the Collier Trophy is considered the highest aerospace event of the year. And so the Ingenuity team, and these are all the NASA folks that were awarded the Collier Trophy for this year. Here's Susan Gordon right here. Very, very good friend of mine. So with that, I'll take some questions. I did find this was kind of fun. I guess they started a new photo of the week. I guess Perseverance or Ingenuity will snap pictures from the previous week, and then I guess NASA will post a couple pictures up in this one spot on their website, and then people vote for it. And so this was the picture of the week for February 11th or 5 through 11. So it's just kind of a cool picture, I thought. I don't know, maybe I'm excited about a rock, but so that's it for me. I'll try to answer any questions if there are any.
Sure. Thank you, Susan.
Thank you very much.
Yes. If you guys want to ask a question, probably come up a little closer to the camera, and we'll
I have a question on the helicopter itself. Being a coaxial design, you get rid of most of the torque yaw, but you still have residual yaw. I'm just kind of curious how the rotors work there. I assume the collectives, the rotors are tied together, and on the cyclic function, I'm not sure, but how do you control for feathering, pumping, and dragging? In other words, the minute control, because I don't know how to get the directional control, because without a tail rotor, and I didn't see any deflector plates, I'm not sure how you have some very complicated rotors there is what I'm saying.
Yeah, and there's it is controlled centrally there. There's some pitch control. It's all there. But again, it has to be programmed in ahead of time. And that's why I think the first flight was so scary, because we really didn't know pitch. We didn't know speed. We really didn't know angle. We didn't know just how it was going to actually respond. But now that we've kind of got a little more flight time under our belt here, we've kind of been able to predict and get that directionality in there as well, so it can move and rotate and then move forward.
Is there speed variation? Are you able to vary the speed or not on that? Can you change the angle of attack on the?
Yes, there's a little bit of, yes, there is some control on that. Yeah.
Hi, thanks for doing the presentation. Appreciate it. I had a couple questions. You said that the helicopter would be used for like reconnaissance out in front of the rover. So I'm wondering if the camera that it has is it actually two cameras so they can do 3D, or is it just a single camera right now for just a 1D view, 2D view?
If I'm remembering all, it looks like it's pretty much 1D. I don't remember seeing, unless it's got something in stereo, but I just have not seen any pictures that have shown anything other than that. I'm not privy to what the cameras they have on it are, but they only look like it's 1D. There's no 3D there.
I would guess in future they'll go to 3D, 2K.
Oh yeah,
So that-
I'm sure. I'm sure the engineers and scientists are just can't wait to put more stuff on it.
Engineers are like that, aren't we?
Yeah. New and improved.
That's right. So you had a note on a slide that said that the RPM was around 2,200 or so. And how does that compare to a terrestrial helicopter? Is that significantly faster? What is it normally on Earth? Do you know?
I don't know, given that diameter. It had to move faster because of the density of the air, but I just don't know. I don't know for something that size on Earth what it would be.
Okay. Last question. Mars has a season for dust storms, and so it has a lot of wind. Has the helicopter has it been out in heavy wind, and how has it dealt with it?
I'm not aware of it being out in heavy wind. I haven't really heard that we've really had any heavy winds there. But what I've heard is that the nights, everything is getting, it's colder than what I think they even expected it. I think, they knew the helicopter was going to shut down, but they say it really shuts down and they have to wake it up every morning now because things are so cold. So
if it's high enough, it might just tumble down the surface there like a bit of tumbleweed. So that would kind of put a damper on a flight outside.
Yeah.
So hopefully.
Yeah.
All right. Thanks. Thanks again.
Thank you.
Next. Thank you very much, for the great presentation, first of all. And we all greatly appreciate that. It was very, very well done, very, very informative too. My question is, I think you said the next mission will be in 2026, and that will be to retrieve the samples. And then if that's right, then when is the mission scheduled to eventually return those samples back to Earth?
Well, let's see here. Right now, well, maybe 2026 was the Dragonfly one. Now so that's the Titan one. The one for the Mars, they have, let's put it this way, we haven't even put the contracts out yet for the design of these helicopters yet. To retrieve them. We're still working with the European Space Agency to have them. They've started designing and building the let's see, this system right here. So they've just started that, but we have not started building this one. I mean, we're kind of putting out feelers, with the contractors, it's like, interest right now in terms of
Dragonfly going to, okay. That's
yeah, that was the Dragonfly. Yeah. Right now we're working with the Europeans to get this set of vehicles off the design board first and start building that, because this one, the helicopter shouldn't take too long, and this one and the launch system needs more funds.
Okay, thank you.
You're welcome.
Hey, Susan, thanks for the presentation. But I got a question about the samples that are being retrieved. So you indicated they're trying to look for possible, astrobiological samples, that kind of thing. Are they looking for like some kind of microfossils or something else like that too? Because obviously if they had seen macrofossils in the cameras, we'd have heard it in the news by now.
Yeah.
Just curious as to what kind of things they're looking for besides just a biologics,
Yeah. Yeah. They know that certain sediments and certain soils will be present in water situations. And so I think I even just read, what was it, a week or so ago, I think I did see actually something in the paper saying, well, they could kind of see, it looked like there were waves lapping up against this wall of a soil area. So it's kind of looking for those types of soils and rock that have a tendency to be in delta water beds anyhow. And it sounds to me like that's kind of what they're starting to find. I mean, at least some of it, I think some of it's kind of interesting, or, it's like, oh, this is an interesting one. I wish I know how they decide, again, they have a whole big panel of scientists that are, trying to decide, where do they drill next?
Yeah.
And
Have they seen any difference in like the strata that indicate that they're looking at like either like a lake type of sediment or maybe an ocean sediment, or they're not that far along or whatever?
Well, you can actually see it visually. If you go on the websites there, you can actually see some of those pictures that Perseverance has taken, pictures of those core samples. And you can kind of see some differences in the layers there.
Yeah, but are they lake samples or oceans, beaches?
I don't know.
Okay.
Yeah, that I don't know. And I don't know how much they know. I mean, all they can do is kind of visually look at this. I'm not aware of any chemical testing they're doing with this Perseverance at all. I think it's all just visual and mechanically doing the coring, and then until these samples come back, I don't think they're going to know what they've got.
Yeah.
Totally.
Okay, thanks.
Mm-hmm.
Good evening, Susan. Thanks for your presentation. I'm Laura Ainsley. This is partly for the club. This is partly you might want to see it, and partly I'm thinking people in the club might want to see this too. The Fort Wayne Astronomical Society is one of the member clubs of the Night Sky Network, NASA's Night Sky Network. And last year, I think it was late last year, we got pins for basically attempting, at least attempting to do public events in 2021 and the first part of 2022. And you have to see what this pin looks like. It's awesome. It's got the Mars helicopter on it.
Oh, okay.
Wow. It's hard to see. I can see it's hard to see, but yeah. I mean, this is a cool pin. I just wanted to say thanks for your presentation.
Oh, thank you. Yeah. Thank you very much.
I was going to ask, when you were at Toledo, did you visit the Ritter Planetarium and spend any time with the 1 meter telescope?
No, I did not.
And for the, do you fly helicopters yourself? You mentioned the Radio Control Club. We have a club about 200 yards from our observatory, and they have several guys over there that have pretty awesome helicopters.
Yeah, no, actually I fly free flight. So I need big wide open spaces. I don't do any helicopter. I don't do any RC. I do free flights. So these are the ones you pretty much let go out of your hand and you've got it trimmed and it's time endurance and hope you keep an eye on it and bring it down after X amount of time.
Julie does rockets if you need a rocket help.
I did that in college.
Yeah, I do high power rockets. Yeah, I'm up to L2. There's an L1, L2, and L3 I've done the L2, and someday I'll do the L3, where you go really up with electronics and the whole gizmo. So, so you said that the helicopter transmits the data to the rover, and then the rover sends it up.
Yes.
So I guess what happens if the rover dies and the helicopter still works? Nobody talks to it, huh? It just sits there and rots away, or?
That's kind of it. Actually, it was pretty much planned the other way around. They weren't sure if the helicopter was going to work, and so we were very specifically told that, you know, if it didn't even get off the ground on the first flight, or nothing happened, or it tipped over and it couldn't right itself, Perseverance was told it was supposed to drive away and move on.
Okay. Goodbye.
Yep.
Don't let the windstorm hit you on the backside.
Yeah, exactly. Yeah, it was kind of one of these. That was part of the rules that we don't have to speculate too much anymore about it. But I mean, we were told, it was going to be given 30 days to try to make those 5 flights. And, when the time was up, it was going to, the rover was going to roll away, but, again, they wanted that rover really far away. I mean, 200 feet away, because they didn't want anything to happen to that rover. And I totally understand it. But yeah, we clearly knew what the rules were. 5 flights, and the rest was history.
I guess there's no chance for a glide. I used to fly gliders, get inside the glider and fly. We used to say parachute, radios, and motors for sissies. So I guess there's no chance in that atmosphere to fly a glider then.
No, I've been in a sailplane a couple times. I like gliders. Yeah.
Me too.
Yeah, just find those thermals. Well, that's what our free flight models are all about too. You try to launch them in thermals.
Yeah. Thank you. Thank you for your presentation and helping out the club with. We really enjoyed it. So let's give her a round of applause, everybody. Anybody else?
Yeah, I'm gonna see if there's anybody else from the.
See if any online questions.
Online at Peanut Gallery, I guess, let me see. Anybody out there, Gene or Larry or Neil, have any questions you want to ask Susan before we start showing comet pictures?
Neil's got his hand up.
Oh,
Okay,
yeah.
well, unmute yourself and ask away, Neil.
Wake up, Neil.
Okay. So actually, that was applause. Thank you for the information. Great insight to the whole process. My background's chemistry, not engineering like some of the others, so I don't have any questions at the moment. Once again, thank you for the presentation.
Thank you.
Okay. All right, well, we're gonna launch into looking at some comet pictures. Susan, you're welcome to listen or exit the stage if you like, it's fine, but we're gonna pop up some emails, so. I'm gonna get rid of your screen share and then we're gonna pop up some pics, okay?
Okay, sounds good. Thank you very much. I appreciate the request.
Okay, you're welcome.
All right. Thank you.
Okay. And let's see. Adrian. Okay. Adrian Day sends her comet picture from, I think this is her EV scope, which is working pretty well.
She even has a,
She's not going through the pain curve. She just sets this thing up on a tripod outside of her apartment and takes a picture. It's disgusting, you know.
she even has a galaxy in that one.
Yeah,
Yes.
yeah, she did.
Yes, it was.
Oh, go back, I didn't see the galaxy.
You were confused.
Okay, let's see if I can get the group here. Yeah.
Yeah.
Okay, that was Adrian Day. Sky Safari, Pastor Linsley. Okay, here's some more comet pictures. Let's see, here's another EV scope comet picture from Adrian. 88 seconds.
I don't think that was Adrian.
Yeah, that's Bill Rejefty.
Oh, it is?
He's got one of those scopes too.
Yes, he does.
Cheater.
Hey, he was using technology to its advantage.
Yeah,
Where's the
something's wrong.
pain? You're like the guy in the commercial, where's your mask?
At my age, I
You
got
gotta,
enough
you
pain.
gotta
I don't
get them to
need
bring
pain.
the scope.
Okay,
out
was
for
this
public viewing.
Adrian?
Bill's willing to do it.
Right,
Yeah, there's supposed to be a program about that.
Yes, he is.
okay.
It's like November.
Who's that?
This is the one, this is from Adrian. 17, 16, 15. Okay, Bill Rejefton. This is Bill Rejefton. You're right. Yeah, that was Bill. This is Bill's. And then there's another Bill. Right.
That's supposed to be a color picture as well, but I don't really see much.
I
color.
see a little
see the
purple and
green.
stuff
Little bit.
around here. Yeah.
Yeah.
Yeah. Okay, let's go back to 14,
He needed to
13.
process.
Joe says very nice. Okay, what is this? Oh, this is the movie.
The movie.
Yeah.
Comet, the
Comet the
movie.
movie.
You saw
Yeah.
the picture, now see the movie.
Yeah,
Is it up for award?
here you
We're
go.
gonna do an IMAX on it.
Yeah. Okay, so somebody did a movie. Oh, this was an Adrian Day movie that she popped them together.
What? She's getting good.
I know.
Well, her scope's getting good.
Hey, she gets some credit.
So
She had to
when
lay out
she
the-
uses an automated scope, it's her scope getting good, but when you use your automated scope, it's your getting good, right?
Get better.
She's getting pretty good with it. I think that's great. All right, let's go back to the eyepiece or what's the eyepiece? That's 4.
Bill application.
Code for signing into Zoom. Oh, that's on Zoom. I thought we were on Comet, I thought. Okay.
I'm putting up Gmail here, actually.
This is, okay.
Oh, that looks.
Yeah, it was until I clicked on something. No, I'm not really good at multitasking here.
That's mine.
This is
That
you?
was taken with the 80mm guide scope or finder scope on
Oh.
the 16.
Joe Novosel. Yeah,
Yes,
very good.
That's why I know what it is. And I was able to identify a couple stars, T-Town up there using
Okay.
a plate solver software that we have on the laptop.
Uh-huh.
And yeah, so that's the 80mm. It's got about a, well, I forget, 3-degree field of view, maybe. Yes, the stars are extremely fat. It's not really a great photo. I will admit that.
I don't know. I think it's cool. You can see it. You can tell what it is.
It's virtually unprocessed. This was taken through the 16.
Okay.
So this was taken at about, turns out to be about f9.
Mm-hmm.
on the scope, and the camera was a ASI 178 with fairly short exposure, but still, I wouldn't say the tracking was very good.
Okay.
Yeah, so
So that's why you get a little bit of streaking.
that's right. That's
Yeah.
why it gets.
But you can see the comet. That's
That's
cool.
right. And yet another one a little bit later, I think.
Uh-huh.
And still, this was on the 16th.
Okay.
And software involved was ISIS for flats and dark frame subtraction.
Yeah. Sorry. Did something. I don't know what I did.
That's all I had. Was just
What? Okay. Oh, wait. Is that it? Oh, there we go. Okay, that was you, right? Then here's Geddes. Geddes took a picture with his iPhone. Look at that. You can see the comet with his on an iPhone right there.
That's not it.
That's not it?
No. It's up
Okay.
to the right, but he did get the comet in that picture on an iPhone.
The comet is where? Are you sure?
It's right,
Here's
if
his
you go to the
index.
right there, there's I think that's the star that was close, it's really close to that star right there.
that's
I
all.
have it on my computer
Okay.
and a close-up of it.
You
So,
think this is it?
but, yeah, no, that's not the comet, that's the star.
Okay.
It's down to the left of that. And you cannot see it on that,
Not a 1X.
no.
So what's this thing then?
That. What
That
are we looking
is,
at there?
Serious.
Serious.
Oh, yeah.
Yes.
But where's, this is not the belt?
Yeah, that's right.
Well, if that's the belt, then Sirius would be in line here, you know what I'm saying?
Yes.
Oh, okay. That was Geddes. And then another, oh, is this the eyepiece? Yeah, we don't want to see the eyepiece. We can all read that on our own time. And then here's another observing report. This is another Adrian setup. And that's a nice picture. That is, you can see two tails, it looks like.
No,
Is that Adrian?
I think it is Adrian.
Yeah, she's getting good. She could get rid of the circle on the. It's Adrian. Okay. And let's see what it says right there. Adrian says, last night's clear skies gave me the Monday the 13th. That was Adrian. That's all I got for comment. Is there something on your flash drive?
Yeah, that's good. That's good.
Okay. All right.